Hello and welcome to my channel. In this video we will be discussing about shear force of a cantilever with UDL when the load is uniformly distributed. So suppose this is a cantilever, this is the free end, and we have a uniformly distributed load on this cantilever. So in this case, how we will find the shear force? Suppose this UDL is 10 kilonewton per meter. This entire length is 2 meter. So again we will have to start from the free end. So suppose we are at this free end and we are assuming a section XX at a distance x from the free end. Now at a distance x from the free end, when we calculate the shear force, we have already discussed the shear force will be equal to the, at any section xx will be equal to the sum of all the vertical forces acting on this section on this point, either left of the section or right of the section. So suppose this is 10 kilonewton per meter. Suppose a person is standing at this section XX. When he stretches his hand and sees towards his right, this is the right hand in this way. So he will see this UDL acting on it, and this is UDL, that is load is kilonewton per meter. So if this is the x length, then the load will be equal to the will be, as it is uniformly distributed, so load will be 10 into x. So it is 10x. Now again, if we take any section here, then again the distance will be x. So it will remain, shear force at this section will remain 10 into x. Similarly, up till point B, wherever we take the section, suppose at point B we are taking the section and seeing towards our right, then the load will be 10 into x and x will be equal to 2. So shear force at B will again be equal to 10 into x, and this will be equal to, x will be equal to, at B x is equal to 2. So 10 into 2, because x is equal to 2 at B. So we will have a shear force of 20 kilonewton at B. Now what is the difference with the point load? Here the expressions comes in the form of x. So if we have drawn this in this way, that our free end is towards the right and left, the fixed end is towards the left. This is because we want to show that this dependence 10 into x or w into x. So what is happening actually, suppose this was the beam AB and we have this UDL acting here. So from the free end, as we move toward this in the x direction, as x is increasing, you can see the shear force is increasing, 10 into x. When x is 20, x is 2, shear force is 20. When x is 0, shear force is 0. So this is 20, and since this is, we can say, if we denote shear force by y, then it is depending upon x. Y is a function of x, and how it is changing linearly, because the equation is fx is equal to 10x. So we have to draw a linear curve that shows that shear force is continuously increasing or linearly increasing with distance. As the distance from the free end is increasing, the shear force is increasing. When the distance is 0 from the free end, the shear force is 0. So in this way we will be able to see, based on this equation, whether it is y is equal to f of x is a function of a power x, that is linear, or ax square, or a into x power 0. Depending on this, we can decide whether the shear force diagram drawn is correct or not. The shape, depending upon the shape, we can easily identify whether the shear force diagram is correct or not. So we will explain this a little bit more. So this is the shear force diagram where this is 20 and 0. Suppose as we have discussed earlier in the previous case, that point load, when there is a point load on the beam, then how shear force diagram, what is the shape of shear force diagram? So in case of a cantilever with a fixed, with a UDL, this will be the shape of shear force diagram. If suppose instead of UDL there was a point load acting here, 10 kilonewton or 20 kilonewton point load acting at this location of cantilever, then if we would have taken any section here, then only force towards our vertical force towards our left will be this 20 kilonewton, and as mentioned in the previous video, we would get the shear force diagram where shear force is 20 kilonewton everywhere, and we will have a shear force at any section xx will be equal to 10 kilonewton and 20 kilonewton everywhere. This will be 20. So what is the difference between these two? In this case, shear force is a function of shear force is equal to 10 into x. At any section xx, it is equal to 10 into x. So here it is y is a function of fx in terms of linear equation, a power x, a into x, and here it is a function of x, it is independent of x, and if we write y is equal shear force at xx is a function of y is a function of x, then it will be equal to 20 into x power 0. What is x power 0? X power 0 is 1 for x not equal to 0. So in this way we can write 20x is equal to 20 is equal to 20 into x raised to power 0. So which shows that the shear force in case of a point load is independent of x, that is the distance from the free end. But in case of UDL, it is not independent of the distance from the free end. So it is linearly varying, and this will be the shape of shear force diagram for the point load. Shear force diagram will be like this. This is A end and this is B end, and for the case of UDL, the shear force diagram will be linearly varying. If we want to directly check the shape of shear force diagram, if we directly check the shape of shear force diagram, suppose somebody has drawn shear force diagram for point load like this, then we can, without checking the calculation, we can say that this is wrong. Or in case of UDL, if he has drawn the shear force diagram in this form, then we can directly say that this shear force diagram is wrong without checking any calculation. So in this way we can, depending upon the form of equation, we can directly check the shape, what should be the shape of the shear force diagram. Thank you for watching our video. In the next video we will discuss about the combination of UDL and point load on a cantilever.